Kia ora. Let's look at the ionic radius now and see how it changes in the periodic table. So we've looked at atomic size. So these are the atoms. And as we saw in the previous video, our atomic size decreases from left to right across the period. Similarly here also for period 2. But notice that the anions over here and cations are different, so it doesn't follow the same trend. We have it getting smaller, but then there's a sudden increase and then it gets smaller again. The same thing in period 2 for its ions. So why is this? The first term we need to look at is the term isoelectronic. This means iso, the same, electrons for electronic. So if we look at the nitride, oxide, and fluoride ion, and the sodium, magnesium, and aluminium ions, we can see these are isoelectronic because they all have 10 electrons. Nitrogen normally has got 7 electrons, but because it's gained 3 electrons to form the nitride ion, nitride has got 10 electrons. Oxygen has got 8 electrons, but because it's gained 2 to form the oxide ion, oxide has got 10 electrons. The same thing for fluoride. Fluorine gained an electron to form fluoride, so fluoride has 10 electrons. Sodium had 11 electrons, but it lost 1, so it is now 10 for the sodium ion. Magnesium also only has 10 electrons because the magnesium atom that had 12 electrons lost 2. Aluminium had 13 electrons, it lost 3, so the aluminium ion is also only got 10 electrons. And you can see that there is a decrease in size if we start from the previous period and we go down. Now, why is that? So in the last video, we looked at Coulombs Law, which you don't have to know, but it's a good way of seeing how you the force of attraction between the nucleus and the electrons is based on the charge of the nucleus and on the electron, as well as the distance between them. Now, we've in the past really always considered the force of attraction, but we also have a force of repulsion. So if we have 2 electrons here, they are both negative, so they will repel. But again, the further apart they are, the less repulsion, and the closer they are, or the more repulsion, or the bigger the charge or the change in charge. But electrons don't change in terms of charge. So let's take this hypothetical hypothetical atom where I've got 3 electrons in the first energy level. This is to avoid shielding and inner electrons and so on. So I know it's hypothetical because there is no atom that can have 3 electrons in the first energy level. The maximum is always 2. Now, what happens if I add another electron? So what will happen to those 3 electrons that are present in there? If it comes in, that electron is going to repel these others. So we're going to have this force of repulsion. So to keep that same repulsion, they have to go, if these other 3 have to move further away so we can keep the same repulsion between them. And so the more electrons we add, the bigger the space those electrons will take up, simply because of the repulsion between them. So let us look now at the cation that's formed over here. So this is the lithium atom, and this is the lithium cation. In the lithium atom, my valence electron is in the second energy level. So it doesn't feel the full effect of the 3 protons, the nuclear charge, because there is some shielding from the inner electrons. When I form the cation, the major change is, of course, that we have lost an energy level. So the valence electrons are now, first of all, a lot closer. So remember D for distance. If that's smaller, then the attraction becomes a lot bigger. So that is a main difference. And then also, because there's now no shielding, they're going to feel the nuclear charge of 3 protons rather than an effective nuclear charge of the 3 protons minus the shielding. So our cation is always smaller than the anion. Than the atom. For the anion, it's the other way around, where the anion is always bigger than the atom. And this is simply because we've added an electron, and as we saw in the previous slide, that will cause repulsion, so those electrons have to move away from each other to allow room for another electron in there. So if we look at our trends here as what we saw in the first slide, metals on the left hand side of the periodic table lose electrons to form the cations, and those on the right form anions. For isoelectronic cations, the more electrons lost, the smaller they are. So B3 plus is a lot smaller than lithium plus. These all have got 2 electrons, so they're isoelectronic. And the nonmetals, as I said, form the anions because they gain electrons. And in this case, the more anions, so we're going from fluoride to oxide to nitride, the more anions, the more repulsion, so the bigger the anion. So I hope you've understood all those points of the changes in the ionic size compared to the atom and the changes within the isoelectronic series. Goodbye.